Okay, so for the product rule, if you have a function that is equal to the product of two other functions, then the derivative, all right, and again, this is a rule, this is something you have to learn, okay? The derivative is equal to the first function times the derivative of the second function plus the second function times the derivative of the first function. All right, so let me let that sink in. It's the first function times the derivative of the second function plus the second function times the derivative of the first function. Okay, and as you are writing that down, I will go ahead and put up our first example. Okay. All right, so again, this is a rule that we are going to learn how to apply. All right, so looking at our first example here, so here we have a product, right? It's a multiplication of two different functions. And technically we could FOIL this out, right? If we didn't have a product rule, we would want to multiply this completely out, all right? And then we could take the derivative. But the product rule allows us to skip that process. Okay, we do not have to FOIL this out. All right, so then how would this look? All right, well, the first function is 6x plus 5, and that stays the same. Go back over here. All right, so we have the first function, and now we need to multiply that by the derivative of the second function, which just requires a basic power rule. Okay, then we're going to add, and we're going to keep the entire second function the same, and we're going to multiply it by the derivative of the first function. Okay, and so this is why, like, I keep having the speed quizzes to kind of get you, you know, accustomed to taking derivatives, you know, quickly. All right, so now we just need to simplify this thing. Okay, now simplifying oftentimes does require some distributing. Okay, and so for this one, we're going to distribute the 3x squared. All right, and then we have a plus, and then we want to distribute the 6 because we probably have some like terms that we can add together. All right, and that's it. That's the answer. Okay, any follow-up questions to that? All right, so like I said with that one, oh, say that again. Yeah, you do need to simplify these. I think in Delta Math, sometimes it says it doesn't matter, you can put it in any form, but I feel like you need to practice simplifying them. Okay? Because like on a quiz or a test, like if it's multiple choice, or like I guess a test, the multiple choice test, you're going to have to be able to recognize it in simplified form. And then when you use the product rule for anything in like a free response, you usually need to simplify it so that you can do something else with it. So even when Delta Math says you don't have to simplify it, you should practice simplifying it. Okay, that was a good question. All right, so my next one here, all right, this time I have a trinomial times a binomial. And this starts, you know, hopefully you can see that this is when the product rule would really come in handy, because I don't know about you, but I don't want to sit there and have to try to FOIL or multiply this whole thing out before I take the derivative. Okay? So we're going to go straight into our derivative, and as you take the derivative, you should kind of say the rule to yourself, right? So that you start to learn that rule, right? And what it says is it's the first function. Make sure you leave it in parentheses because you're going to multiply it by the derivative of the second function plus the second function times the derivative of the first function. All right, and now I just want to give you a couple of minutes to try to simplify that one, please. All right, so so after you take the derivative, you need to do a little distributing, a little foiling, and then adding like terms. Okay? Now, let's bump it up a notch. All right, what if I tell you that your function is, I don't know, x squared times x plus 3 cubed? Okay? All right. Well, just by like letting me know with a head shake, is this something that I could actually distribute the x squared first? Could I distribute the x squared before I took the derivative? Head shakes. All right, and chat boxes. Okay, good. I see several no's because the x plus 3 has an exponent. You are correct. Okay, so you cannot distribute here. And if you didn't want to apply the power rule, or excuse me, the product rule, you would have to actually cube this whole thing out. You'd have to multiply it by itself 3 times before you could distribute that x squared. So that's why it's really nice to have a product rule. Okay? All right, so let's go through the rule. My derivative will equal the first function times the derivative of the second function. What rule do I need for that derivative? What rule do I need to take the derivative? Yes, Nick, the chain rule. Very good. All right, the power chain. That's a good way to say it. All right, so you would apply the power rule, but then because it's more than just x, you need the chain. All right, so all of that is the derivative of the second function. All right, plus the second function times the derivative of the first. Okay, so now we need to clean this thing up. All right, so for the first piece here, we're going to just multiply our constants, our coefficients, and we're going to bring that to the front. And then maybe for the second one, I'll put the 2x in front of my parentheses cubed. Okay? All right, well, the one thing I don't want to do is have to try to FOIL this thing out now. Okay? And so there's a different way to simplify this one. You can factor out a GCF. Okay, this is going to be it's going to leave you with the most simplified answer. All right, so that means what is the GCF between this whole piece and this whole piece? Okay, because the addition between them is what separates them into 2 terms. And I want to know what is the greatest common factor between those 2 big terms. All right, so I look at the number in front, 3 and 2, they don't have anything in common. All right, how about x squared and x? What do they have in common? Okay, so I can take out an x. And then I have an x plus 2 squared and an x plus 2, x plus, oh, I copied that wrong. It should be a 3. An x plus 3 squared and an x plus 3 cubed. All right, so the GCF there is the smaller one, the one with the smaller exponent. Okay. All right, so now that I have taken that out, I'm going to use a bracket because I got a bunch of stuff left over. All right, you can use parentheses, it doesn't matter. All right, now that I'm taking that out, I have to figure out what's left over from each big term, each big chunk. All right, so let's see. I still have a 3 here and an x and nothing else. Then I bring down my plus. I still have a 2. I took out the x, and I took out 2 of the x plus 3's. That means I have 1 left over. Okay? And then that leaves me with something that should be a little easier to simplify. Okay? So I have an x, I have an x plus 3 squared, and let's see, that's going to be 2x plus 6. And so when I add like terms, I'm going to get a 5x plus 6. And so that is my derivative, my final simplified answer. And that this is a skill that you need in order to move forward, right, with this class. Because think about it, if you start doing an application problem, like a velocity, like a position velocity acceleration problem, and you have to figure out where the derivative is equal to 0, okay, then you would want to know what the factors were so that you could solve the equation. All right, how did I make the exponent go away in the second piece? Okay, so it didn't really go away. All right, keep in mind my GCF took out x plus 3 squared. So that means I had to take 2 x plus 3's out of this one, and it was left me with 1 x plus 3. Good. All right, and so no, don't be sorry. I want you to ask questions like that. That's good. Okay. Any other questions on this one? All right. Let me give you one similar to that. I don't know. I want to talk about. I'm going to give you a minute to start this one, but then I want to talk about how you would factor this one to kind of look like what we just did. Okay, so take a minute and at least set up the product rule. All right, see if you can clean it up a little bit, and then we'll talk about how you would factor it. Okay, so we kept our first. We have the derivative of our second, which requires a power rule first, but then because the inside is more complicated than just x, we need the chain rule. So we need the derivative of the inside. Then we have plus the second times root of the first. Now I'm going to clean this up a little bit by multiplying, right? The things that don't have the addition or subtraction, I should be able to multiply all those together and bring that to the front. Okay, so I can clean that up a little bit. And then for the second piece, I'll just put the 2 in front of my parenthesis. Okay, now I want to talk about how we could go about factoring this one, similar to the last one. Okay, so I look at my entire, like when I look at it, I think of it as 2 separate but big chunks, okay? Because the stuff that's connected by multiplication, that's all one piece, and then there's a plus, and then everything else is connected by multiplication. So we have 2 big pieces. And the GCF, let's see, they both have a 2 in common. You're welcome to take out a -2 if you'd like. Just be careful when you do that, okay? So they both have a 2 in common, and then they have a common factor inside the parentheses, but remember, you have to take out the smaller of the sets. Oh, why didn't I get a -4x squared? Because of this 1/2 right here. It was -4x squared, but then I still had to multiply it by 1/2. So then it went back down to a -2. Good question. All right, so my GCF, I took out a 2. You're welcome to take out a -2. Here, I'll even write that over here. If I take out a -2, because it'll look a little bit different. That's supposed to be a 1. Okay, so then what would be left if that's what I took out? All right, well, if I don't take out the negative, I have a negative x squared left for this term. But then at least I took out the entire 1 minus x squared to the negative 1/2. All right, in the other one, since I took out a positive 2, it would still be a plus. And we talked about this the other day, okay? Think about, all right, that's what's there right now, right? I'm just kind of bringing this over here. That's what's there right now, and I want to take out a 1 minus x squared to the negative 1/2. Well, taking a factor out is the same thing as dividing by it. Okay? Well, then how do you combine those exponents? Like, how do I put those two things together? Anybody want to take a shot at that? Good, Philip. Anybody else? Before I tell you what he said? So what you would end up doing is you would end up actually bringing the bottom up to be a positive 1/2, but then the two factors match, so all you do is end up adding a half to this power, okay? And then that ends up being left as 1 minus x squared to the first. All right, yes, Elson, I'll go back over that in just a second, okay? All right, and okay, so going back over the GCF, like how do you take it out? So I'm literally looking at these two pieces. This is all one big piece, this thing I'm underlining in green, and then this is one piece. So those are like my two main terms that are added together. So I want to know, what do they have in common? Okay, so it looks like they each have a 2. Right, they each have a 2. And then they each have this 1 minus x squared, right? But they're both raised to a power. So the GCF is the one that's raised to the smaller power, and that's going to be the negative power. So that's why I took out a 2 and a 1 minus x squared to the negative 1/2. Well, then I have to figure out what's left from each big chunk after I take those things out. Okay, and so if I take out the 2 and the 1 minus x squared to the negative 1/2, the only thing that's left for my first piece is the original negative in front and an x squared. In the second piece, when I take out the 2, that's good. But then I have to figure out, how on earth do I take out something with a negative power from something with a positive power? So that's when I came over here and I said, okay, remember, taking something out is like dividing by it. But if I divide by a negative exponent, by something with a negative exponent, it's the same thing as adding the positive exponent. Okay, and so that's how I ended up with 1 minus x squared to the first. All right, well, let's finish simplifying that real quick, and then I'll show you the other one. Okay, so because this is now raised to the first inside here, I don't really need that parenthesis. I don't need that exponent. I don't need those parentheses. And so I can combine like terms, and I always tend to write my positive term first, so I'm going to do the positive 1 minus 2x squared. Because a negative x squared and another negative x squared makes negative 2x squared. Okay. All right, and then last but not least, I need to write it so that I don't have any negative exponents. So that just means that whole piece with a negative exponent is going to move to the bottom. Now, if you want to change it to a square root once you put it on the bottom, you're more than welcome, but you certainly do not have to. Okay, but that's going to be your answer after you completely simplify it. Now, what I was talking about over here is what happens if I decide that the GCF, I want to keep the negative with the 2 when I take out the GCF. Okay, so then what does that change for my leftover stuff? Well, then the x squared that's left over will be positive, but the 1 minus x squared that's left over will be negative. And that requires distributing the negative to combine like terms. And so that one ends up being positive 2x squared minus 1. And even though they don't look exactly alike, they actually are the same thing. They actually are the same thing. Because you can see that your factor on top is switched, which is exactly what would happen if I distributed this negative in. Okay? Let me give you a chance to ask me questions on that. So, for our next problem, all right, let's look at x times e to the x. All right, and again, because this is two functions with x's in them, right? You've got more than one x in the problem. So that's how you know that this is two different functions of x multiplied together. You need the product rule. Okay? So the product rule says first times derivative of the second, which happens to be itself, plus second times derivative of the first. All right, and then you can clean that up because you don't need to write times 1. You can factor it. And that's it. That's the whole thing. All right, so I try not to give you one that was too complicated there. But just understand this does apply with all the other functions that we've done. Stop me if you have questions. All right, let me give you one with a trig function in it. Okay, again, we have multiplication of two things that have x's in them. And so that's how we know that this is a product rule, because there's two different x's in the problem. Okay? So we have first times derivative of the second plus second times derivative of the first. Now, I guess if you wanted to factor out an x, you technically could, but you don't need to. You will when we get into the solving portions. You will have to be able to factor everything. But for the ones that are nice polynomials like this, if you leave it unfactored, that's not a big deal.